What exactly is Tornado Alley? Tornado Alley isn't an official term you'll find on a weather map. It's a nickname meteorologists and storm chasers use to describe the central part of the United States that sees the most tornado activity. Traditionally, it includes Texas, Oklahoma, Kansas, Nebraska, and South Dakota, though the boundaries are often debated. This vast region experiences hundreds of tornadoes every year, many of them among the strongest ever recorded. But what's fascinating is that the concept of Tornado Alley isn't about one single factor. It's the perfect mix of geography, climate, and atmosphere that combine to make tornadoes more likely here than almost anywhere else on Earth. The geography of Tornado Alley. If you look at a map of North America, you'll notice that Tornado Alley sits right in the middle of the continent, in an area with few mountains and open, flat plains stretching for hundreds of miles. That geography plays a massive role. Mountains can block or redirect air currents, but in this part of the US, there are no natural barriers between the north and south. This allows cold, dry air from Canada to flow freely down from the Rocky Mountains and the Great Plains. At the same time, warm, humid air moves up from the Gulf of Mexico. When these two air masses collide, it sets the stage for some of the most explosive weather on the planet. The collision of air masses. The secret ingredient behind Tornado Alley storms is contrast. Tornadoes thrive when warm, moist air meets cold, dry air, a clash that creates massive instability in the atmosphere. Here's what happens. The warm Gulf air rises quickly when it meets the denser cold air from the north. As it rises, it cools and condenses, forming towering cumulonimbus clouds, the kind that spawn severe thunderstorms and supercells. These supercells are the factories of tornadoes. They produce violent updrafts and downdrafts, hail, lightning, and sometimes a rotating column of air known as a mesocyclone, the structure that can eventually tighten into a tornado. And because Tornado Alley regularly experiences this air mass collision, especially in spring and early summer, the region becomes a breeding ground for these violent storms. The jet stream's role. There's another key player that makes Tornado Alley so active, the jet stream. The jet stream is a fast-moving river of air high in the atmosphere that separates warm and cold air masses. It often flows right over the central United States during the spring. When the jet stream dips south and curves over Tornado Alley, it helps create wind shear, a sudden change in wind speed or direction with height. This wind shear tilts thunderstorms and allows them to rotate, which is essential for tornado formation. So when you combine surface-level instability with strong upper-level winds, you get the perfect setup for long-lasting, rotating storms capable of producing deadly tornadoes. Why spring is tornado season? While tornadoes can happen any time of year, most of them strike during spring and early summer. That's because spring is the season when the contrast between cold and warm air is strongest. Cold air still flows south from winter, while the Gulf of Mexico pumps in moisture from the warming ocean. During this time, daytime heating increases instability, making thunderstorms more likely to explode into powerful supercells by late afternoon. That's why most tornadoes occur between 3 p.m. and 9 p.m., when the atmosphere is at its most energized. As the seasons progress, the jet stream moves north, and so does Tornado Alley's activity, shifting from Texas and Oklahoma in spring to the Dakotas and the Midwest in summer. The Great Plains, nature's tornado laboratory. The Great Plains region, the heart of Tornado Alley, is almost like nature's laboratory for tornadoes. The land is mostly flat, which allows storm systems to travel for hundreds of miles without obstruction. There are few forests or mountains to block the flow of air or to slow down rotating storms. This unique setup gives meteorologists and storm chasers a clear view of developing systems. That's why the US has the most advanced tornado detection systems in the world, including Doppler radar networks and mobile storm chasing teams. It's also why more tornado research is done here than anywhere else. Every spring, scientists head into Tornado Alley to gather real-time data on how these storms form, evolve, and die out, helping improve warnings that save lives. Why other countries don't have a Tornado Alley. While tornadoes can happen almost anywhere, Few regions on Earth experience them as frequently or as powerfully as the central United States. Countries like Canada, Argentina, and Bangladesh do get their share of tornadoes, but none have the same combination of geography and climate patterns. For example, in Europe and Asia, mountain ranges, deserts, and coastlines break up the airflow and prevent the kind of large-scale collisions that fuel tornadoes in America. The US just happens to sit at the intersection of polar air, tropical moisture, and flat terrain, a rare recipe that's almost impossible to replicate elsewhere. The shifting tornado alley. Recent research suggests that Tornado Alley might not be fixed. It's slowly shifting eastward toward Mississippi, Alabama, and Tennessee, an area some scientists now call Dixie Alley. There are several reasons for this change. Climate variations may be altering temperature and moisture patterns, and the Gulf of Mexico's warming waters could be providing more fuel for storms farther east. This shift has serious implications. Unlike the open plains of Kansas or Oklahoma, the southeastern U.S. has dense forests and rolling hills that make it harder to see approaching storms. Many homes there lack basements, and nighttime tornadoes are more common, making them deadlier. So while Tornado Alley still exists, its danger zone is slowly expanding into new territory. Tornado Alley's human impact. For the people who live in Tornado Alley, tornadoes are a way of life. Towns across Oklahoma, Kansas, and Texas have sirens, shelters, and emergency systems ready to respond within minutes. But despite all the technology, the power of these storms remains humbling. The 1999 Moore, Oklahoma tornado reached winds of over 300 miles per hour, one of the most powerful ever recorded. The 2011 Joplin, Missouri tornado destroyed a third of the city and killed more than 150 people. These tragedies highlight both the fury of nature and the importance of preparation. Modern forecasting has reduced casualties dramatically, but Tornado Alley's residents never forget how fast conditions can turn deadly. The future of Tornado Alley. So, will Tornado Alley always exist? Meteorologists say probably, but its shape and activity could keep evolving. Climate change isn't making tornadoes more frequent, but it may be altering where and when they happen. Warmer air means more available energy for storms, and higher humidity levels can fuel supercells farther east than before. At the same time, improved radar systems, drones, and AI-based forecasting models are helping scientists predict tornadoes with greater accuracy. The goal is to extend warning times from minutes to possibly half an hour or more, enough to save countless lives. In the future, Tornado Alley may look different on the map, but its legacy as the world's most powerful storm zone will remain.